Good morning. Good morning, student. Today we are going to discuss about the next topic in the first unit, that is DC circuits and Kirchhoff laws. Before going to the next class, we are going to discuss about last class. We try to recall the previous class topics. What we are discussed in the last class, we discussed about the different types of electrical materials and about the resistance and about current and voltage. What are the different materials? Generally, we discuss about the insulator, conductor, and the semiconductor. The property of the resistance, definition of the resistance, and the units of the resistance we discussed, and about the current. What is the current? The flow of electrons are called as the current that is measured in terms of the amperes, and also discussed about the voltage, that is the electromotive force which moves the electrons from one position to another point are called as the voltage. The units are volts. And also we discussed about the connections, that is resistances are connected in series. What is the total resistance and what is the series connection? And also we discussed about the parallel connection. What is the parallel connection? How the current divides and how the voltage divides across the resistors. Today, today we are going to discuss the following topics. Those are DC circuit terms, active and passive elements, their circuits, junction, loop branch, and remaining thing, and the last one is Kirchhoff laws. So, what are the DC circuit terms? Different terms. We need to know the electrical terminology, so that we are able to understand the concept of the electrical circuit. What are the active elements? What are the passive elements? What are the different circuits we are going to discuss? In the circuit, we having the junction, loop, branch, etc. What is the junction? What is the loop? What is the branch? Like that, we are going to discuss about all these related uh, topics to the circuits, and moreover we are going to discuss very important topic, that is the Kirchhoff laws. These laws are used to calculate the voltage and currents in the circuits. So now we are going to discuss about the electrical symbol. What are they? You can see how we write the symbols in what way. You can see different electrical symbol. You can see battery having the two terminal, plus terminal and minus terminal. You can see there the plus electrode should be more greater than the minus electrode. A wiring the electrical wire should be drawn with the line. And voltmeter, you see here voltmeter in the circle we represent with the V. Ammeter which represent with the A. Resistance, you see here how the resistance is represented. Capacitor, junction, terminal, AC generator, variable resistance, variable capacitor. These are the symbols for the different elements which we are used in the circuits. You see here another representation: conducting wire, junctions, wires crossing, resistor, capacitor, inductor, variable resistor, switch, and remaining things are there. Switch. Okay. Switch. Next, lamp is there. Circuit symbols, you can see another symbols are there. A battery representation, how it is battery, and AC battery, simple battery, voltage source, ammeter, voltmeter, ground. As these are the representations for the circuit symbol. Whenever we are going to draw the circuit. We need to know all these things, how we can represent a resistor, how we can represent a voltage, how we can represent a voltage source, current source, and ammeter, voltmeter, in what way we need to connect, because these elements should be uniform to the every student and every person, so that he can understand what he written, what they taught to them. So for that purpose, universally we need to have the universal symbols and universal codes. We having the SI units are there. You can see for the capacitance should be represented with the C. The units are farad. The charge is represented with the Q. The units are coulombs. Current represented by the I. The units are ampere, which can be represented by the capital A. Electromotive force, the units are volts. V. Frequency is measured in terms of the hertz. The unit symbol is Hz. Inductance measured in terms of the Henry, capital H. Time period is represented in the second, that is a S. Potential difference is measured in terms of the volts, that is a V. Power measured in terms of the watts. The watt representation is W. Resistance measured in terms of the ohms. The representation is ohm symbol. Temperature measured in terms of the Kelvin. The units are K. Time is represented in the seconds, that is S. These are the standard SI units we going to represent in the circuit. Whenever the uniform symbols and uniform circuits are drawn, each and everyone can understand, each and everyone get the same values, same uniform solutions for the circuit. You can see different types of prefixes which we are going to use in the circuit representation. That is the tera capital T, that is for the 10 power 12, giga 10 power 9, mega capital M, that is a 10 power 6, kilo capital K 10 power 3, milli 10 power minus 3, micro 10 power minus 6, mu nano 10 power minus 9, pico 10 power minus 12. These common prefixes are used to represent the values of the elements, that is the capacitance, inductance, resistance. These values can be represented by using these prefixes, because the more the values we to understand, to calculate easily, we use these type of prefixes. You can see. So what are the basic concept in the electricity? The basic concept is mainly the electrical circuit need three things, that is voltage, current, resistance. An understanding of the basics of electricity requires the understanding of three fundamental concepts, that is voltage, current, resistance. A direct mathematical relationship exists between voltage, resistance, and current in all electronic circuits. The voltage, current, resistance. You see what is the current? You see here the representation is by the under ampere, the French physician. The definition is current. Current is the flow of electrical charge. Current is the flow of electrical charge through an electronic circuit. The direction of a current is opposite to the direction of current flow. Current is measured in terms of amperes. You see here the electrical charge through an electronic circuit. The flow of electrical charge is called as the current. The current is measured in terms of ampere. The current direction is always opposite to the electron direction. We need to remember this direction so that we can conventional. In the last class we discussed about the conventional direction. The conventional direction is from the positive to negative, but the electron direction is from the negative to positive. Next one is the voltage. You can see how represent voltage. Alessandro Volta, the Italian physicist, he represented this one. Voltage is the electrical force that causes current to flow in a circuit. It is measured in volts. The meaning is the voltage is the electrical force. That force causes the current to flow. Whenever this force is applied to the conductor itself energizes the electrons, and the electrons move from the positive to the negative or higher charge to the lower charge. Next, the current. We can see the current. The first analogy you can see how it is going. You can see volts, and then current you can see. The analogy we can see the flow of water from one tank to another is a good analogy for an electrical circuit, and the mathematical relationship between voltage, resistance and current you can see. What are the relationship between voltage, resistance and current? You can see the force is nothing but the difference between the water levels, that is nothing but a voltage. The flow of the water between the tanks is nothing but the current. Opposition, the valve that limits the amount of water, it is nothing but a resistance. Like this we analyze the physical properties with the electrical properties. We can see simple model, that is a water flow model. In the water flow you can see in the tank, from the higher two tanks are there. From one tank to another tank we try to transfer the water. In these two, the difference heights between the two tanks is nothing but a voltage, and the flow of water is nothing but a current. The opposition is nothing but the valve. Whatever the valve is there, that valve controlling is nothing but a resistance. This is in the electrical circuit. You can see electrical circuit having some basic terminology. Electrical charge. What is the electrical charge? An amount of electrical energy is called as the electrical charge. That charge may be positive or negative. Electrical current means the flow of electrical charge, often a flow of electrons. Conventionally, current is in the opposite direction to a flow of electron. The electric current means a flow of electrical charge, often a flow of electrons. Current flow in a circuit. How the current flow in a circuit? A sustained current needs a complete circuit. Also requires a stimulus to cause the charge to flow. The meaning is the circuit should be complete. It should have the closed loop. Otherwise, it does not go the current. And another one is electromotive force, or you can also call it as a potential difference. The stimulus that causes a current to flow in an EMF. This represents the energy introduced into the circuit by a battery or generator. This results in an electric potential at each point in the circuit. These forces, electromotive forces, are used to transfer the electrons from higher position to higher voltage to the lower voltage. This is the electromotive force. Between any 2 points in the circuit, there may exist a potential difference. Both EMF and potential differences are measured in volts. You can see, we try to understand what are the different currents we have. Generally, we having the two types of currents: direct current and alternating current. Direct current. What is direct current? Currents in electrical circuits may be constant or may vary with time. When currents vary with the time, they may be unidirectional or alternating. When the current flowing in a conductor always flow in the same direction, this is direct current. When the direction of the current periodically changes, this is alternating current. So these are the main difference between the direct current and alternating current. Whenever the direction of the current is same and does not change with respect to the time, that is called as the direct current. The current which having the periodical shift in the direction, that is called as a direct current or alternating current. The main important one is the Ohm's law. Ohm's law is a very important law to identify and find the voltage, current, resistance in a simple DC electrical circuit. The relation between the voltage, current and inductor voltage, current and resistance is called as the power triangle, voltage triangle. The current flowing in a conductor is directly proportional to the applied voltage and inversely proportional to its resistance R. Ohm's law triangle V equals to IR. From this we can write anything. If you know any two components, we can find the another value. That is, if you know the V and R, we simply find the I value. If you know voltage and current to the circuit, we can simply find the resistance. The voltage, the Ohm's law. What is the Ohm's law? The Ohm's law states that the ratio of the potential difference between any 2 points of a conductor to current flowing between them is constant, provided temperature of the conductor does not change. The meaning is, without changing the temperature, the ratio of the potential difference or voltage, the ratio of the voltage between any 2 points of the conductor to current flowing between them are constant. That is, the ratio between the voltage and the current flowing through the conductor is constant. So that is it states by the Ohm's law, that is V by I is equal constant. That is, the constant is represented by the resistor R. So what are the limitations of the Ohm law? Ohm's law also having some limitations. So some limitations are: for metals which are heated by the current to large extent, for electrolytes where enormous gases are produced on either electrons, for vacuum tubes, arc lamps, for gas filled tube in which the ions are generated as the current passes. All these are not used for the Ohm's law. The Ohm's law is not applicable for all these things because these properties are changes with respect to the time. So now we try to discuss about the various terms used in electrical circuits. Circuit. What is the circuit? We can say the definition, simple definition: a circuit is a conducting path through which either an electric current flows or is intended to flow. The thing is, the circuit is the circuit. It provides the conducting path through which the either current, electrical current flow or is intended to flow. It may flow or it may provide the path for the future purpose of the flowing the current. Active elements. What are the active elements? The source may be voltage or current sources which supply energy to a circuit or network are known as the active elements. You can know that we have the two types of elements, active element and the passive element. Active elements are those elements which provide the energy to the circuit or which supplies the energy to the circuit are called as active elements. Another classification is passive elements or circuit parameters. Passive elements are the elements which can accepts, which can accept the energy or which does not deliver the energy, are called as the passive elements. The various elements like resistance, inductance, and capacitance are called passive elements or circuit parameters. The circuit also different types of there. Another one is a linear circuit. A linear circuit is one whose parameters are constant. That is, they do not change with voltage or current, are called as a linear circuit. Generally, we can say a linear circuit is one whose parameters are constant. That is, they do not change with voltage or current. The properties or parameters of the circuit does not change whenever you are applying the voltage or not applying the voltage. Non-linear circuit. A circuit in which the parameters change with voltage or current is known as non-linear circuit. Unilateral circuit. A circuit whose properties are characteristic change with the change of the direction of its operating current is known as unilateral circuit. The meaning is a circuit whose properties are characteristic change with the change of the direction of its operating current is known as a unilateral circuit. Unilateral circuit. The bilateral circuits. We having the different circuits like that you can see. Bilateral circuit. A circuit whose properties or characteristics are same in either direction is known as bilateral circuit. A unilateral circuit having the unidirectional properties. Whenever you apply the direction of the current, it changes its directions. Coming to the bilateral circuit, the properties or characteristics are same in either direction are known as the bilateral circuit. The next one is the active circuit. What are the active circuit? The circuit where the active elements are involved like voltage source or current source are known as the active circuits. Generally, always the DC circuit or simple electrical circuit needs a active circuit because the active circuit supplies the energy to the network or circuit. The another one is the passive circuit. What is the passive circuit? The circuit in all elements are only the passive elements like resistance, inductance, capacitance. Are called as the passive circuit. The circuit we are using the different elements, active elements and passive elements. How we can connect the circuit? To connect or whenever we are connecting we get some junctions or nodes. The junction we can say like this junction in a network or circuit, a point at which two or more elements are connected and where division of current takes place is known as junction or node. At the point two or three junctions or two or three branches are connected at a single point or at a point the current is divides, that point is called as the junction or node. The branch you can say is the a part of the network or circuit connected between two junctions is called as branch. You can simply say a branch is nothing but a part of the circuit it is connected in between the two junctions or two nodes. So you can also say that loop or mesh. What is the loop? You can say in the circuit, loop means whenever the current founds the closed path, that is called as a loop. We can also call as a mesh. A loop is a closed path and may contain active or passive elements or both. That type of circuit is called as a loop. So the thing network circuits, how what is there? In many circuits, resistors are connected both in series and in parallel. Generally, the DC circuit involves only with the resistors only. The AC circuit may have the capacitors and inductors. These networks, such circuits is called a network circuit. In many circuits, resistors are connected both in series and parallel. The series and parallel circuit is called a network circuit. There is no single formula for adding resistor in a network circuit. For very complex circuits, electrical engineers use computer programs that can rapidly solve equations for the circuit using Kirchhoff laws. If you know the total resistance and current, use Ohm's law as V equal to IR to calculate voltage or voltage drops. If you know the resistance and voltage, use the Ohm's law as I equal to V by R to calculate the current. An unknown resistance can be found using Ohm's law. R equal to V by I if you know the current and the voltage drop through the resistor. Using the Kirchhoff law, current law and voltage law, two laws are there in the Kirchhoff's law. Kirchhoff voltage law. The sum of all of the voltage drops in a series circuit equals to the applied voltage. Kirchhoff current law. The total current in a parallel circuit equals to the sum of the individual branch currents is called as the Kirchhoff current law. These two are very important topics. Kirchhoff voltage law, Kirchhoff current law. The current law says that the total currents in a parallel circuit equals the sum of the individual branch currents. Whenever if you take the circuit, we can find this KVL and KCL. All electrical circuit analysis requires the use of two fundamental laws called Kirchhoff voltage law. Kirchhoff voltage law. So we can see like this. Kirchhoff voltage law. All electrical circuit analysis requires the use of two fundamental laws called Kirchhoff's law. You can see Kirchhoff current law, very simple law. At a node, sum of the entering currents equals to the sum of the leaving current, or the sum of the currents at the junction are equals to 0. So like this, we can find the any currents at a junction by using a Kirchhoff current law. The total current into a junction equals the total current out of the junction. By using this unknown current, we can measure. In the circuit, you can see 3 amps and 3 amps are entering into the junction and 2 amps and 1 amps are leaving. If you summon that, the 3 amps equals to the 3 amps. 3 amps current is going to the junction and 3 amps current is going out from the junction. The total current flowing into a node is equal to the total current that flows out of the node. The mathematical expression of the KCL is as following: sum of the entering currents equal to the sum of the leaving currents. So this idea gives the unknown currents. Simply we can find the currents in the circuit. The Kirchhoff current law. You can see how we can there in a single branch. I is the branch current. We must have sum of the currents equal to 0. In a circuit study, current flows in Y's. Consider a node in a circuit. I1, I2, I3. You can see I1 leaving, I2 leaving, I3 leaving. So what is the meaning? I1 plus I2 plus I3 equal 0. We have for a node in a circuit, the algebraic sum of all currents leaving a junction must be 0. At any instant, the algebraic sum of the currents flowing into any junction in a circuit is 0. That is I1 minus I2 minus I3 equals to 0. I2 equal to I1 minus I3. From that we can find the 7 amps. You can see a circuit like this, 10 amps and 3. We need to find the I2 by applying the KCL. At the junction, we can find the value as the 7 amps. Kirchhoff circuits law, you can see. First law says that all current entering a junction point must equal all current leaving that junction point. You can see the junction point. At that junction point, entering currents equals to the leaving current. I1 equals to I1 plus I2. When using Kirchhoff's law, we apply the principle of conventional current flow. When current leaves the positive terminal of voltage source and enters the negative terminals, a voltage rise across the source. You can see the battery. If the current enters the positive and exit the negative of a voltage source, a voltage drop across the source, you can see like this. V equal to minus 6 volts. You can see how it is. Battery plus minus 2 terminals are there. Current always flows from the plus to minus 6 volts. Current flow plus 6 volts. You can see. When tracing a current loop, if the assumed direction of the current and the loop direction are the same, a voltage drop across occur a resistance. You can see, if the assumed direction of the current and the loop directions are opposite, a voltage rise occurs across that the resistance. V equal to 60 voltage drop. Then another one is the Kirchhoff voltage law. At any instant, the algebraic sum of the voltages around any loop in a circuit is 0. Algebraic sum of the voltage around any loop in a circuit is 0. For example, you can say E minus V1 minus V2 equals 0. From the circuit, you can see how it is V1, V2 and supply voltage is there. If you write the KVL minus plus E minus V1 minus V2 equals to 0. What we needed is, we need the V1, you know already. Capital E. Capital E equals to 12 volts. So that is 12 minus 7 equal to 5 volts. You can see Kirchhoff voltage law. Algebraic sum of voltage drops around any closed path within a circuit is equal to the sum of voltages presented by all of the voltage sources. The mathematical expression of KVL is as follows. Sum of voltage drops equal to sum of voltage source. The algebraic sum of voltage drops around any closed path within a circuit is equal to the sum of voltages. You can see the Kirchhoff voltage law, very simple law. How they represented like this: 1 amps and that minus 3 volts we are applying, 1 volt, 2 volt. What happens means, you see here, the total voltage drop or gain around any loop of a circuit is 0. In this you can see the voltage drops minus 3 volts, minus 2 volts, 1 ohm, and the 1 amp current is there. You can see the Kirchhoff current law, how it is. Second law, you can see around any complete loop, the sum of the voltage rises must equal the sum of voltage drops. The thing is, if you measure in terms of volts, sum of voltage rises must equal the sum of voltage drops. You see here how it is flowing. The battery voltage equal to V1 plus V2 plus V3. Example for the loop circuits. The loops are nothing but a complete current paths in a circuit. Kirchhoff's law, around a loop, sum of voltage rises equal to sum of voltage drops. A loop is a completed path for current flow. You can see loop 1, loop 2, loop 3 also there. For a closed circuit containing voltages, sources and resistors, we have sum of voltages equal to I into sum of resistances. We can, that is a series circuit, so we can calculate the total resistance of the algebraic sum of the EMFs around a closed circuit equals the algebraic sum of the voltage drops over the resistance around the circuit. So now we try to discuss about the summary what we learn in our class. So we are discussed in the topic Ohm's law and limitations of Ohm's law. So what is the definition of Ohm's law? What are the conditions of the Ohm's law where we are using the Ohm's law? Another topic is definition of various terms using in circuits. Different terms we try to understand, because the circuit terms should be known. Statement of Kirchhoff laws and the definition of current and the voltage. Now we are going to discuss about the quiz. A part of the network or circuit connected between any two junctions is known as. You know already that branch means between the two nodes. The answer is branch. According to Ohm's law, the applied voltage in a circuit is proportional to current square of current resistance. So what we can say? Current. The units of the current is, you know already, that is amperes. The important questions are: what are the differences between active and passive circuits? You know already active circuit and passive circuit. Active circuit means the circuit are the elements which can supply the energy to the remaining circuits are called as the active elements. Passive circuits. Passive circuit means the circuit which does not involve with the frequency are called as a passive circuit. The circuit elements which can store the data. State the limitations of Ohm's law. We try to know the Ohm's law understanding, and we need to know the limitations where we need to apply, where we did not going to apply Ohm's law. That is represented by the imitation of Ohm's law. Define electric current. You can see the electric current will be defined. Defined voltage. We are going to define the voltage. So these are the topics we are discussed in this class. You can see that's remaining things. So next class we are going to discuss about the problems on KVL and KCL, how we are going to apply these simple Kirchhoff voltage law and current law to the circuit. Then only we can understand in what way we can find the voltages across each and every element, how we can find the current through the elements. So in that we can also having the different methods, different connections. Resistors we not only simply connected in series, we not only connected in parallel. Sometimes we include both series and parallel within a circuit. So sometimes we require to simplify the circuit. So whenever there is no useful to the series circuit simplification and parallel circuit simplification, then we go for the another technique called star to delta. The star to delta circuits are very important. So what it makes that wherever you having the star connection, that star connection easily converted into the delta connection. So whenever we having the delta connection, we can modify into star connection. That is a very important thing. So this transformation useful to reduce the circuit and find the simplified equivalent resistance from the circuit. So another one also there. So remaining also there. So in that circuit also we need to find the node voltage and the branch currents. If the number of nodes are increases, what we need to know. So for each node we get the each circuit equation. So number of nodes increases, number of equation increases, and the number of variables are increased. So in order to avoid that, we can use the mathematical, that is the matrix representation. Whenever you have the circuit, that circuit is divided into two ways, that is the mesh analysis base or node analysis base. In the node analysis, the each node is written as a single equation. After getting the equations, they can find the unknown value. Coming to the another one, coming to this, can see. Thank you for watching this video. If you have any doubts and any clarification, you can ask me so that I can rectify these things in the next video. Thank you.